In this video, we're going to solve quadratic inequality algebraically. How are we going to solve x squared minus 3x minus 4 is less than 0? Well, first, let's pretend that this is x squared minus 3x minus 4 equals 0, and find x values that makes this whole thing equal to 0. Using factoring, x minus 4, x plus 1. Now make sure you double check by multiplying it out. So you end up getting x equals 4, x equals negative 1. Okay, this is x minus 4, x plus 1. It has to be less than 0. Now let's draw a line. And let's put negative 1 and 4. Make sure this goes in order, smaller to larger. Now we're going to get some numbers that are greater than 4 and plug it over here. What happened? Let's choose 5. 5 minus 4 is 1. 5 plus 1 is 6. And when you multiply those, you get positive. Which means that any number that's greater than 4, when you plug in over here, you will get positive. Try 10. Try 100. Now, what will be a nice number to test from negative 1 to 4? 0. 0 is always nice. So 0 minus 4 is negative. 0 plus 1 is positive. Negative times positive is negative. Any number between negative 1 and 4, you choose, you plug it in, you end up getting negative. What about any number that's less than negative 1? Let's say negative 5. Plug it in, what happens? You get negative, you get negative. And negative times negative is positive. So now, in order for this statement to be true, it has to be negative. Only negatives are less than 0. So that means solution is over here. Any numbers that are greater than negative 1 and less than 4, that will make this statement true. Let's take a look at another example. You got x squared plus 3x greater than or equal to 2. So how to solve it algebraically? Well, first you got to move 2 to the other side. And let's pretend this is 2x squared plus 3x minus 2 is greater than or equal to 0. I'm sorry, equal to 0. So we could factor this. Again, if you forgot how to factor, make sure you guys review how to factor. So this is going to be 2x, you got x, plus 2, and then minus 2. And make sure you multiply it out, see if you get this. So you end up getting x equals 1 over 2, or x equals negative 2. So you get 2x minus 1, x plus 2 is greater than or equal to 0. And let's draw a line. And let's put this in order. You got negative 2, and you got 1/2. Now we're going to test which region gives you a positive and negative. So what would be a good number to test over here? What's the number that's greater than 1 over 2? Well, let's try 2. You could choose 3, 5, it doesn't matter. Let's try 2 and plug it in. You get 2 times 2 minus 1, that's positive. 2 plus 2, positive. So positive times positive is positive. So any number you choose that's greater than 1 over 2, you plug in over here, you end up getting positive. What's a nice number to choose from here? 0. When you plug in 0, it's negative 1 times 2, which is negative. So again, any number you choose between negative 2 and 1 over 2, and plug in over here, you end up getting negative. What about over here? What's a nice number to choose? Well, negative 5 or negative 4, it doesn't matter. Plug it in, you end up getting negative times negative, which will be positive. So now, in order for this statement to be true, it has to be greater than or equal to 0, which means this has to be positive. So our solutions are, it has to be x less than or equal to y, because we have underline now, then -2, or x has to be greater than equal to 1/2. So this will be our solution for this problem. Now they want us to solve 3x squared minus x minus 5 greater than or equal to 0 by graphing. And it's nice that they're asking us to solve by graphing, because this is not factorable. And you probably have to use a quadratic formula to get the x values. And yeah, if you don't do graphing, this problem can be very nasty. So how do we solve by graphing? Well, first, this represents a y value. So we need to find when does the y value is greater than or equal to 0, which means when does the y value become positive. So using decimals, I graph 3x squared minus x minus 5 equals 0. And here's a parabola. And I found the x-intercepts. You can find the x-intercept by clicking the where the graph crosses the x-axis. So I have two x-intercepts. And this is supposed to be irrational numbers, meaning that it represents some radical numbers. So now we want to find when this is greater than or equal to 0. So when is y? When is y greater than or equal to 0? That's when x is less than -1.135, because the y values are positive over here. And that happens when when x equals less than -1.135, or when x is greater than equal to 1.468. So what happens in between then? What happens between -1.135 and 1.468? Well, that's when y is less than, because y is below the x-axis. That's when y is less than or equal to 0. So to answer this question, we know that this will be greater than or equal to 0 whenever x is less than or equal to -1.135, or when x is greater than or equal to 1.468.